All right, so part 2 of this video is going to continue with completing the packet, but we're going to pick up with chapter 10. So chapter 10 started, well, it's all about circles, really. So you've got to know some vocabulary here. There's not a lot of vocab, but basically, like enough to get through a question. You're not going to be asked these specific just to identify it, but you do want to know what those are. In 10.1, we had a couple of theorems. One that said where the tangent meets the radius, it forms a right angle. So in something like this would be a right triangle. And then I could set up, using the Pythagorean theorem, I would say that r squared plus 5 squared would equal r plus 3 squared, and then expand and FOIL that. Same thing for 10. 11 was that ice cream cone theorem that just basically says that two tangent lines would, from the same point, would be equal. So I would set 2x plus 7 equal to 3x minus 5, and then solve, and you'll get the 12. That's the same for number 12. I would set those equal to each other. 13, set them equal to each other. 14 is just a little bit more, because this would equal this, and then that same side would equal this side. These two would also be equal to each other. So same theorem, just applied in a couple of different ways. 10.2, you just want to know, these are now minor arcs, major arcs, and semicircles, properties of these circles, identifying what kind they are, what the measure is. So all those central angles, which are going to form that 360, and then the central angle is the same as the arc. So this is 75, this one would be 30. If this is your diameter, you would add these and subtract them from 180 to get that missing angle in here. So 75 and 30 is 105. Subtract that from 180. 105. And you get 75. So this is 75, making this 75. And then vertical angle still applies in a circle. So if that's 75, then that's 75. And then there's only two angles on this side. So 180 minus 75 would give you 105 here, which gives you that angle. So you've just got to work through the properties of central angles for that stuff. Same thing for 10.2. That's just like drawing a diagram. It says in circle C, so this is C, arc AD is, so let's just make an arc AD is 50 degrees, and B bisects arc AD, so B would be in here. Now this is 25 and 25. E is the diameter, so come across here, this would be E, and then find the measure of the arc. So this would be 180 degrees, which would mean this is also 180 degrees. Subtract that one, or subtract the 50 from it, it's 130. So AED, remember the order of the letters is important. AED goes all the way around except for the 50, so that I would subtract the 50 from there, making it 310. BD was this little part in here, which would have been 25 because it's half the 50. DE would take you from here to here, which is the 130. And BAE, so we're going B, which is in here, AE, the 25 plus the 180, which is that 205. In 10.3, we learned a couple other theorems that if there's congruent chords, then they form congruent arcs. So if this is if this was 130, then these two would have to be they're the same, and they add up with that 130 to 360. So I would take the 360, subtract the 130, I'd get 230, and then divide it by 2 because these are each the same, and that's where the 115 comes from. And then 26 is yet another theorem that said that if the diameter hit a chord that was perpendicular to a chord, that it bisected the chord, so these two would be equal, and the arc. So those two would be the same as would these two. So 125, this would be 125. That's 250. Subtract it from 360, and you get 110. Divide that by 2 and you get 55 and 55. Same property is used in 27, just on the reverse side. So again, that's a diameter perpendicular to a chord, which is kind of what's going on in 10.3. You don't really have to justify anything, so you can get to know those properties, but you won't be using them to justify like the way that these questions are. Okay, 10.4 was about the intercepted arcs from inscribed angles. So remember, inscribed angles equal 1/2 the arc. So, you know, this angle here being 40 degrees means that this arc here would be twice that, or 80. And then this is the diameter, so this would be 100, making y half that, which is 50. And then this would also be 180, which makes this half that, or 90. And that's pretty much 32, kind of the same idea. 33, you're dealing with two angles that intercept the same arc here. So these two are congruent. I would set this equal to this. And then on the reverse side, this angle and this angle also intercept this same arc, so they're congruent. I set this equal to this, and then just solve it. And then we got into quadrilaterals inscribed in a circle, and these, the opposite angles, would be supplementary. So if I did x and 75 have to add up to 180, subtract the 75 from the 180, that's where you get the 105 from. And then the other way, y plus 95 would have to equal 180, subtract, and you'd get the 85. 35 is the same, you just have variables involved, and then 36, same property. Except actually this time you need the measurements in the outer part of the circle, so it gives you 56, 168, 224, plus 88, 312, subtract that from 360, and you get what's left over here, which is 48 degrees. And then this guy, 13x, intercepts this whole arc. So 13x would intercept 48 plus 56. Oh, sorry, and this would be 1/2 of it. So 13x would be 1/2, 104. 13x would be 1/2 of 104, which is 52. And x would be 4. So note this one. And then reverse it for the 8y, sorry. 8y would be equal to 1/2, 88 plus 48. 136, half of 136, and 8y is 68, which makes y 68 over 8, which is 8.5, which is fine. Okay, then we got into the angles in the circle. So there was the 3 theorems involved here in 10.5. So the first was that floating angle, or the when two chords intersect inside. Made sort of like an X, but not an exact X. And so the angle inside was equal to the two arcs. The arc it intercepts plus the arc its vertical angle intercepts, and then divided by 2. So if this is A, B, and C, D, then angle 1 equals 1/2 arc AB plus arc CD. The arc it intercepts plus its vertical angle intercepts divided by 2. That's how you would do 37, 38. You'd have to do a linear pair here, so figure out what's happening in here first by subtracting from 180, and then do the same thing. And then 39 was the tangent and a chord. So that angle equals 1/2 the arc it intercepts, just like an inscribed angle. So this angle is 1/2 of that 110, which is the 55. And then we had the exterior angles. So the exterior angle, whether it was formed by two secants, or a tangent and a secant, or two tangents, the exterior angle equals the big arc minus the little arc that it intercepts, divided by 2. So if you look at 40, exterior angle is 75, so 75 equals the big arc here, which is 12x plus 3, minus the little arc, which is 5x, divided by 2. So I can multiply by 2 on both sides, combine like terms, subtract the 3, and x would equal 21. 41, so same, it's still an exterior angle. I need this arc first though. So I do 110 plus 92 and subtract that from 360. $158, and then I would do 158 minus 92 divided by 2, which is your 33, and that's what this equals. So 33 equals 10x plus 3, subtract the 3, and divide by 10, and x is 3. 42, you're actually dealing with this arc here. Actually, don't worry about 42 because you'd actually have to find this angle using, this would be 8, so this would be tangent would equal 6/10, and then find that angle in there and then subtract from 180. You won't have anything like 42, so don't worry about it. Okay, 10.6 was now dealing with all of the stuff, segments inside a circle. So the first type was again two chords. If two chords intersect inside a circle, then the lengths of the products of their lengths are equal to each other. So A times B would equal C times D. So in 33, if this is x, then 15 times x would equal 6 times 5. 15x would equal 30, and x would equal 2. 41, x plus 1 times 10 would equal 5 times 12. And then just distribute that and solve that. 45, 4 times 3 would equal 3x times x. And again, multiply that and solve. And then we had two secant segments, which is the next theorem. Two secant segments, and this is the whole times the external of one would equal the whole times the external on the other. So if you look here, the whole length here would be 8. 8 times the external part, which is 5, equals the whole length here, which is x plus 4, times the external part, which is 4. And then distribute the 4, solve for x, and you'll get 6. And then 47 and 48 are the last theorem in this, which is a tangent and a secant. And this would be tangent squared equals the whole times the external. So looking at this, 12 squared would equal the whole thing here, 3x plus 9, because 3x plus 1 plus 8 would be 9, times 8. So 144 would equal 24x plus 72. 144 minus 72. 72 and 72 divided by 24 is that 3. 5 would be the same thing. So this would be now a tangent squared, which is the 2x squared, equals the whole thing. So x plus 2x is 3x, and 2 plus 5 is 7. So whole would be 3x plus 7 times the external part, which is x plus 2. So that one you'd have to FOIL out. There's nothing really that complicated on it. You just need to know this theorem to know the whole times external and the tangent squared equals whole times external. All right, 10.7 is your finding the equation of a circle. So remember that it's x minus h plus y minus k squared equals r squared. HK is your center and r is your radius. So it's really pretty easy. It's something like 49 or 50 where you have to just say, okay, if let's say go to 50. If 2, negative 3 is your center, then it'd be x minus 2 squared plus y minus a negative 3 comes plus 3 squared. And then let's say it gave you the radius instead of the point on the circle like 4. Then it would be 16. So it's more like 49 than the point or missing the variables. And then you would just want to know how to, actually, no, you don't even have to worry about having to graph it. Just make sure you know how to find the equation. Okay, the good news on chapter 11 is there's not a ton of stuff from here. So what you do need to know is the length of the arc. So remember the equation for the length of an arc is the measure of the arc over 360 times the circumference, or 2 pi r. So that'll get you like number 1. So this would have been the measure of the arc. If this is 90, then that's 90 degrees over 360 times 2 times pi times 3. And then if you actually work that out with your calculator, it's going to give you the decimal 4.71. So it'll either say keep it in terms of pi, where I would take this and I would reduce this. This would be 1/4 times 2 times pi times 3, and 2 goes into 4 2 times. So this would be 3 pi over 2. Or if it says to round the decimal, then it would look something like that. So same thing for 2, 3, and 4. You just have to cut it in half to get because it's giving you the the diameter. For 11.2, now it's the area of a circle. And actually, it's not going to ask you for area of a circle. You're going to go straight to areas of a sector. So the second formula, so this is, again, a formula you want to review. Then area of a sector is the measure of the arc again over 360 times the area, which is pi r squared. So for something like number 9, this would be 45 over 360 times pi times 5 squared. And again, you can use the calculator. This is over here. Number 9 would be 9.82. And it says area of the sectors formed. So first you're finding the red, which is that. And then the blue, I would do 360 minus the 45 to get the 315 as your central angle, and then still multiply it times pi r squared. Don't worry too much. Actually, you got off good with not having to know the perimeter or the area of the polygon. You do have probability questions, so make sure you review these. So finding the area of the probability of landing in the area that's shaded, you would, for something like number 21, you'd have to find the area of the equilateral triangle, and then subtract it from the circle to leave you with the shaded. So circle minus triangle over the whole thing, which would be the circle. Something like 22, you'd have to do the circle again, minus this whole sector and this little, or just find the area of that sector and subtract from it the area of this triangle, put it over the whole thing. 23, finding the area of the whole triangle and then subtracting from it these two smaller triangles. That'll give you the shaded region, and then put it over the whole thing. And 24, finding the area of the rectangle and then subtracting from it 2 circles and putting it over the area of the whole thing, which is the rectangle. So these are in percents. You'll get the choice. You can either choose if you want to give it in terms of in terms of a fraction or a decimal, depending on what the directions say. So just pay attention there. Okay, then the probability, don't worry about this yet. We're going to come back to this in chapter 12. So the rest of that you can kind of... All right, 11. So this is where all the formulas come into play. So you want to review surface area and volume of a prism, a pyramid, a cylinder, a cone, and a sphere. Make sure you know all those formulas, which again are in your the Quizlet for this chapter, so it's probably a good idea to look back over. So I'll just do a couple of quick ones. Number 30, find the volume of, this is a rectangular prism, so volume here would just be length times width times height. So I would take 4 times 3.5 times 2, and that gives you that 28. 31 is a little bit harder, so this volume is base area times the height. So the area of the base, and the base is this triangle, would be 1/2 14 times 14, or 7 times 14, 7, which is 98, and then the height is 20. So volume would just be 98 times 20, which is that 1960. We get a cylinder here. Volume of a cylinder would be pi r squared times the height. So pi, the radius would be 1/2 this 2.3 because that's your diameter. So the radius is 1.15 squared, and then the height is 7.2. So this, you'd use your calculator, multiply all that out, and you get the 29.91. Okay, volume of a cube. So this is working backwards. Don't worry about this. You just got to be able to find it. Volume of the solid and round to 2 decimal places. So you're going to have a solid in which you don't have to use your area of the polygon. So don't worry about 37, 38. You would want to know how to do something like 36. So volume of a pyramid is 1/3 the base area times the height. The base here is a square. So 12 times 12 is 144. That's your area. And then the height there is 15. So the only other thing you need to know in this stuff is make sure that if you didn't have the height, but had the slant height, that you would know how to find the height. So you would cut that 12.5 to get the 6. And then whatever the slant height was, you would use the Pythagorean theorem to find the height that's missing. So that 1/3 times 144 times 15 is this 720. Oh, 720. Okay, volume of a cone. So a cone is 1/3 pi r squared h. 1/3 pi. The radius is what's missing here. But actually, oh, this is a 45, 45, 90 triangle. So good review. 45, 45. This is A, this would be A, this would be A root 2. So if this is 18, then this is also 18. So your radius is 18, and your height, that's squared, and your height is 18. So 18 squared times 18 times pi divided by 3, which is 6,107.256. So again, this would round, you know that 6 is going to round that up to the 0.26. All right, so something like 41, don't worry about, you're not going to have, like sine and cosine and tangent inside a cone. Just make sure you can apply your formulas to this stuff. And then a sphere, they're not too tricky. Just remember, surface area and volume of a sphere. So surface area would be 4 pi 13 squared for this, and then I would multiply that all out and get 2,123.6 72. And then volume 4/3 pi r cubed. So this one would be r to the third. And then again, just multiply that all the way out to get 9,202.77. Don't worry about similar solids. You can skip that part too. Okay, chapter 12 was your probability. So you want to be able to do simple probability, like something like in the beginning, it says a bag contains 3 red. You've got 3 red, 3 blue, 3 yellow. You toss a coin and then draw the marble out of the bag at random. Find the number of possible outcomes in the sample space and then list them. So you don't have to list them, but you've got 3 different things here. You can either draw a red, a yellow, or a blue. And then you can either do a heads or a tails. So a heads with each one or a tails with each one, which is the 6 possible outcomes. What's the probability that the coin shows tails and the marble is blue? So if, you know, there's a red and a heads and a red and a tail and a blue and a heads and a blue and a tail and a yellow heads and a yellow and a tail, one of those out of the 6 are going to be marble that's blue and tails. You toss a coin 3 times. What are the odds against? So now we're talking odds. Remember that probability is different from odds. Probability, you put the chance that it's going to happen over the total amount of chances. And odds, you put the chance it's going to happen over the chance it's not going to happen. So the odds against the coin showing the heads twice and tails once. So now you're going in the opposite direction. So if you think about your sample set here, 3 times you could get a heads all 3 times. You could get a tails all 3 times. You could get heads and then tails, or heads and then tails and then heads, or heads and then tails. And then same thing with tails. Tails, heads, heads, tails, tails, heads, tails, heads, tails. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's right. So there's 8 total options. And then it says, what are the odds against the coin showing heads twice and tails once? So if it shows heads twice and tails once, which is heads twice, tails once, that's 3 of these. Okay, that's what you don't want, that's what against means. That means 1, 2, 3, 4, 5 of the options are what would be what you want. And what's left over is that 3. That's where the 5 to 3 comes from. So you won't have to create your own sample space. Don't worry too much about it. But you do have to know the difference between probability and odds. Okay, 12.2 is where we got to learn about permutations. How many ways can you arrange the letters in the word spring? So if you're not just pulling out a certain amount at a time, but you want to rearrange them, the order is going to matter. You want to figure out how many items are in there. There's 1, 2, 3, 4, 5, 6. So of all of them at a time and rearrange would just be 6 factorial. And remember, you can either do 6 times 5 times 4 times 3 times 2 times 1, or a lot of your calculators had the actual factorial symbol. So 6 factorial is just 720. In 5, it's asking how many different ways you can arrange 3 of the letters. So this is a permutation taken so many at a time. So this would be the P. Tulip has 1, 2, 3, 4, 5, and you want to do it 3 at a time. And the formula for this is n factorial over n minus r factorial. And that's given that it's PNR. So this would be 5 over 5 minus 2. Both these are factorials. This is 5 times 4 times 3 times 2 factorial. And this is just 2 factorial. So these cancel. 5 times 4 is 20 times 3 is your 60 different ways. So the good news is there's not a ton where you got to figure stuff out. There's some straightforward stuff with factorials, with the permutations in that notation. And then you've got to figure out a couple other stuff like this. So you can choose 3 books from a list of 5 books to read for English class. How many combinations of books are possible? So this is now a combination. The order doesn't matter in which you're reading these books. And combination would be the CNR would be n factorial. Zoom in on this a little bit. N factorial over N minus R factorial, just like permutation, except you add the R onto the end. So for something like 10, 3 books is your R, 5 books is your N. So 5 factorial over 5 minus 3 factorial like we just did, but this time you also add on the 3 factorial. So you'd get 5 times 4 times 3 factorial, and then 2 factorial, 3 factorial. These cancel. This is 2 times 1, 2 goes into 4, 2 times, and 10, 5 times 2 is 10. Making a snack tray, you choose 3 of the 5 available bread and 3 of the 6 available types of cheese. How many different combinations of bread and cheese are possible? So you can figure this out separately. How many different types of 3 out of the 5 is what we just figured out, which is 10. And then 3 of the 6, I would do 3, 6 factorial over 6 minus 3 times 3, 6 times 5 times 4 times 3 factorial over, this is 3 factorial and 3 factorial. One of them cancel. This becomes 2 and 1. 6 cancels. That's 20. So there are 10 combinations of bread and 20 combinations of cheese. To find out what the combinations of both are, you would just multiply those together to get the 200. And then you've got all of these combinations. These are just different ways of, they're just straightforward ways of doing the combinations. Good news is you don't really have to worry about the notation in 12.4. But these are all good questions here. So a jack and a club, remember the words and you multiply. And or you add. So 23 is even just easier just to look at it. A jack and a club. There's only one card in the deck that is both a jack and a club. So 1 out of 52 would be your probability. 24 is an ace or a 10. So this is the probability of, again, or would be an add. An ace, there are 4 aces out of the 52 cards. A 10, there are 4 tens out of the 52 cards. So you'd get 8 out of 52, which reduces down to 2 out of 13. A queen or a heart. So this is an or statement with an overlapping. Something can be both a queen and a heart. So you would do probability that it's a queen plus the probability that it's a heart minus the probability that it's a queen that is a heart. So queen, there's 4 out of 52. Heart, there's 13 out of 52. And a queen that is a heart, there's 1 out of 52. So 17 minus 1 is 16 out of 52, which is 4 out of 13. Okay, skip over the notation of 12.5. That's there. Just make sure you be able to, do some word problems with independent and dependent probability, that kind of stuff. If you want extra practice problems from this section, make sure you go back to chapter 12. All right, that's pretty much every kind of concept that's going to be covered on your test. So good luck studying. We'll see you again for the review day.